You're in your galactic space cruiser on your way to Outpost 52, delivering supplies for the small colony there, when alarms begin going off. You scan your displays, but something catches your eye before you can work out what's happening. You don't need a view screen, as the front section of your ship is transparent, like a one-way mirror. A colossal orange and purple cloud is sweeping towards you. There's no time to analyze it. You put the ship into a dive, as steep as it will go. The alarms go crazy, but you're too focused on getting out of danger. The ship rattles, and you think it will break up, but your ship is fast and powerful, and somehow you manage to get underneath it. You look up and see the gigantic plasma cloud go soaring past. Curiosity has bitten you, and you decide to follow it. You program your computer to analyze it. Soon the information is coming back, and you can't believe what it's telling you. This plasma cloud is a wrecker of galaxies. It and others like it have been ending galaxies before their time. You recall your studies back on Earth when you were just a young pilot. There have been studies as far back as the 21st century as to why galaxies were mysteriously ceasing the formation of new stars, causing them to end ultimately. Stars form from thick clouds of gas that have become extremely cold. They condense and, over time, collapse into solid compact matter. There's a famous photograph taken by the Hubble Space Telescope. Most people have seen it. It's called the Pillars of Creation. It's the Eagle Nebula, where stars are forming. They call these environments star nurseries. It's a pretty cute concept if you think about it. But there's a bad guy lurking, and you're following it. It's a vast star wrecker. The wrecker rushes in and sweeps the gas out of these star-forming galaxies at an accelerated rate, preventing stars from forming in the first place. It's like a giant broom. But rather than cleaning up, it's ceasing up, bringing new galaxies to a premature end. Now that you know how dangerous it is, it's best to hang back a bit. Let's see if we can see it in action from a safe distance. It had been a long-standing mystery why some galaxies don't birth new stars. The star wrecker is smart. It hangs around large galaxy clusters. There's one in particular, the Virgo cluster. This is the one that scientists studied and came across the star wrecker. The nearby Virgo cluster is 7 million light-years across and contains thousands of galaxies. When I say nearby, it's about 65 million light-years from us. Not exactly a weekend space cruise away, but it's pretty close in galactic terms. The cluster hurtles through the superheated plasma at speeds of up to 1,000,000 miles per hour. The cluster forms the basis for the large Virgo supercluster, of which the local group, where our Milky Way resides, is a member. Its proximity to us makes it easier for scientists to study. It's also one of the most extreme regions of the universe that we know of. Currently, who knows what else is out there? The Virgo cluster is also unusual, as it's still forming new stars, and we can observe them, such as in the famous Hubble nursery photo. A galaxy in this cluster is called the Messier 87. It was discovered way back in 1781 by a French astronomer named Charles Messier. It looked a bit fuzzy to him, so he called it a nebula without stars. More information on what it was couldn't be ascertained until the 1920s. Messier was well respected and in his lifetime discovered 13 comets. He was born in rural France, the 10th of 12 children. When he was 14, he witnessed a tremendous six-tailed comet in 1744. It was astonishing and was visible to the naked eye for several months. Its effects were dramatic and unusual. It was so bright that it's been recorded as the 6th brightest in history. 4 years later, young Charles saw a solar eclipse from his hometown on the 25th of July, 1748. He knew then that he wanted to explore the world of astronomy. It was meant to be. A lunar crater and an asteroid have been named after him. Nothing is mighty, however, like the Messier 87, or M87. It's a supergiant elliptical galaxy with trillions of stars. It's the second brightest galaxy within the northern Virgo cluster, making it popular amongst astronomers and amateur enthusiasts. Elliptical galaxies are older, low-mass stars with minimal star formation activity. Large numbers of globular clusters surround them. They make up roughly 10 to 15% of the Virgo supercluster. M87 has a supermassive black hole at its core. The black hole was photographed using data collected in 2017 by the Event Horizon Telescope, EHT. It was announced excitedly to the world in 2019. In March 2021, the EHT collaboration revealed a polarized-based image of the black hole for the first time. It was a pretty exciting event. It was the first time that a black hole had been captured. It happened all thanks to the Event Horizon Telescope, which is many radio observatories or radio telescope facilities around the world, all working together to produce a highly sensitive and high-resolution telescope. Another array of telescopes in Chile is called the Atacama Large Millimeter Submillimeter Array, ALMA. They captured high-resolution images of the 51 significant galaxies in the Virgo cluster. That's part of how we know what we know. M87 and other galaxies don't appear to be doing a lot to the naked eye. In fact, in a typical human lifetime, they barely move at all. Yet they are made up of gas, dust, and other objects that move through space at high speeds. They move when affected by the gravity of other galaxies, or dark matter, a mysterious entity that is 5 times more common than ordinary matter. Many galaxies, including our own, are believed to have a halo of dark matter surrounding them. The dark matter can pull more significantly on the smaller galaxies outside the clusters. As the galaxy gets dragged around through space, the star wrecker may come across. Giant clouds of intergalactic plasma, a form of electric gas, can behave like an atmosphere and drain the gas inside the galaxy. It sweeps out the gas inside the galaxy, stripping it of what it needs to make stars. It's hard to grasp the scale of this sort of activity, but that's what scientists now believe has been occurring to some galaxies or the nebulae without stars, as Charles Messier saw it. Now, let's park our space cruiser here and watch this thing in action. What we've been calling star wrecking is known as gas stripping. It's one of the most spectacular and violent external events in space. A scientist from the National Research Council of Canada said that galaxies are moving so fast through hot plasma in the cluster that a vast quantity of cold molecular gas is stripped from the galaxy. It's as though the gas is being swept away by a giant cosmic industrial blower. It's not the sort of clean-out we want to happen in our galaxy. You observe it in action. You're impressed, but equally respectful of its great power. The gas stripping, also known as ram pressure stripping, travels through many galaxies and removes a star-forming gas. The process is very efficient. The gas is behaving differently from the clouds in our galaxy. They aren't forming as many stars as they are in ours. A 21st century study found that the same process happens in smaller groups of only a few galaxies, with much less dark matter. The study looked at a staggering 10,567 satellite galaxies. These are galaxies that exist beyond the enormous galaxy clusters. Most galaxies in the universe exist in between 2 and 100 galaxies. They were able to study such a large number by using stacking. It makes it possible to learn about a collection of faint objects by combining all the information from the objects and making an average characteristic. They ultimately determined that gas stripping, or star wrecking, is potentially the main way that galaxies, predominantly star formation, are shut down by their surroundings. Pretty unfortunate to have such a nasty neighbor. So, now that your curiosity has been satisfied, it's best to leave this plasma cloud and get on with your journey to Outpost 52. You're going to be late now and could be in a whole lot of trouble. While the cruiser turns around, we'll head back to Earth. And back in time, back to 1744, to that night in rural France, where a teenager stood outside, marveling at the night sky and the spectacular vista of the six-tailed comet. And from that moment, was inspired to begin a lifelong quest based on a single question. Perhaps the ultimate of all. What's out there?
Space is a dangerous place. It seems like wherever you go, something tries to get rid of you. So what if you wanted to go up there without a spacesuit? What's good is that your body probably wouldn't explode. Your skin is strong and stretchy enough to deal with all that pressure. You wouldn't freeze right away either. In space, the only way for your body to lose heat is through radiation, which happens very slowly for a relatively cool object like a human body. You would eventually get cold, but it would take a while, or your fluids would evaporate. Keep your eyes closed if possible. Okay, the air would be the first emergency problem here. Your brain wouldn't be able to get oxygen, so you'd pass out within 15 seconds. And within 3 minutes, your brain would shut down forever. If someone rescued you within the first 30 seconds, you might only have some bruises on your skin from all the pressure changes. Hopefully you didn't try to hold your breath before they catapulted you out there, though. In that case, the air in your lungs would cause them to rupture, which again wouldn't be a happy end. But here's a spot where no one would be able to save you: the center of the galaxy. Each galaxy has a supermassive black hole at its center, and these are even worse than you might expect. They eat up a bunch of matter and release an enormous amount of energy. The largest of these gobblers and the hungriest among them are something we call quasars. Well, to be precise with the relations here, quasars actually contain supermassive black holes that eat everything in their way. And these quasars are some of the most energetic space objects that we know about. When something falls into a quasar, it gets really hot and shoots outward at very high speeds because of the strong radiation force. Quasars can deceive you if you try to observe them through a telescope because you might think you're looking at stars. Astronomers also named them quasi-stellar radio sources because the signals were coming from one place, similar to how it goes with a star. But quasars, of course, have a stronger light. They can shine much brighter than a galaxy with billions of stars. But this same radiation that makes them so bright is not such good news for the galaxies where they're located, because these guests are not very polite and they're slowly ripping them apart. Okay, maybe not that slowly. As a black hole eats matter, hot gases circles around it and produces very intense radiation, which then creates a quasar. Scientists use the famous Hubble Space Telescope to study 13 insanely powerful quasar outflows of radiation. This energy can travel at speeds over 40 million miles per hour and reach temperatures of billions of degrees. One particular outflow of radiation they studied got faster and went from nearly 43 million miles per hour to about 46 million miles per hour in only 3 years. The energy these outflows carry is several hundreds of times stronger than all the light our entire Milky Way galaxy emits. And all this hot gas is moving so fast that it can really cause a lot of damage to the host galaxy. It rushes through the galaxy like a massive tsunami, faster than anything we've previously discovered in space. At the same time, it's pushing apart all the potential material that could get together and form new stars. In just 1 year, this quasar wave can push away as much matter as hundreds of suns and create spectacular fireworks. I mean, the light show would be cool, but that seems like an awful lot of wasted material. These things we're discovering can really help us answer the question that's been bothering us for such a long time. Why do big galaxies stop growing after they reach a certain mass? No wonder when the quasars don't even allow new stars to be born. How rude! I mean, a black hole itself can't destroy the whole galaxy. When a star gets too close, a black hole will tear it apart with its strong gravity. This creates a lot of energy and a bright flare too. And even though we can't really see a black hole itself, scientists can at least study these flares. They can measure their energy more accurately than ever before because they look at how the surrounding dust absorbs and re-emits the light from the flares. It's actually similar to how echoes work. Scientists have also used NASA's Chandra X-ray Observatory to study more than 100 galaxies and realized these black holes are consuming thousands of stars, so they could gain more weight. There are different types of black holes. We call smaller ones stellar mass black holes. They're about 5 to 30 times the mass of our sun. On the other end of the scale, there are supermassive black holes that nest in the centers of large galaxies and weigh millions, or even billions of times the mass of the sun. And recent research tells us there are intermediate mass black holes, which lie in between the two extremes. And it seems these intermediate black holes could be small black holes that had been eating lots of stars, becoming bigger. The special buffet a black hole just can't resist is when there's a dense cluster of stars in the center of a galaxy. Yum! So yeah, black holes are mean fellas, but there's still no way they could eat a whole galaxy. A black hole's gravity is just not strong enough, unless there's a quasar around, making its force stronger. Don't worry though, quasars are usually billions of light years away from us. That means we see them as they were billions of years ago, because light takes time to travel. And light years represent the amount of time necessary for that. It's great that we can study quasars, not because they're pretty cool, terrifying, but still cool. But because with their help, we can learn more about how our own galaxy formed and developed. Quasars are part of a larger group of objects called active galactic nuclei. This family tree also includes Seyfert galaxies and blazars. These are not as awesome as their cousins, but okay, we'll give them a short introduction. Seyfert galaxies may look normal in regular images, but they emit a lot of infrared radiation, radio energy, and X-rays. Basically, they're similar to quasars but release less energy, and they have supermassive black holes at their centers too. Copycat. Blazar and quasar sound pretty similar, huh? Still, they're a bit different. The story of a blazar starts in a familiar way. At the center of a galaxy, there's a giant black hole surrounded by a disk of dust, gas, and debris that spins really fast. As the material in the disk falls towards the black hole, its gravitational energy can end up being converted to light. This makes the center of these galaxies very bright, and we call them active galactic nuclei. Some of these active galactic nuclei are not fine with just shining bright, so they shoot out jets of material that nearly reach the speed of light. This is a quasar. But when a galaxy happens to turn so that the jets point towards our home planet, it's what we call a blazar. And yes, it's like Earth is staring down the barrel of a cannon. Quasars and blazars emit jets of particles pointing towards us or in our direction. Scientists believe Seyfert galaxies are different because they emit jets pointing away from us, which is why it's harder to detect them. These jets from blazars can release particles with lots of energy that we call neutrinos. A couple of years ago, scientists discovered a single neutrino that traveled from a supermassive black hole in a blazar located about 4 billion light-years away. This was so exciting because we've captured neutrinos from only 3 cosmic sources so far: our Sun, a supernova, which was a powerful explosion that happened in a nearby galaxy in 1987, and now from the blazar.
Black holes are like omnivores. They'll eat anything in their way if it gets close enough, including planets, stars, clouds of gas, or some very unfortunate intergalactic travelers. Not that it really gets hungry and goes after space objects, it simply swallows whatever comes nearby. It stretches giant space bodies until they're thin, like spaghetti, and rips them apart atom by atom. A black hole is a huge amount of matter that comes in a very small package. It's like you squeeze a star 10 times bigger and more massive than the sun into a small area with the diameter of New York City. You get an extremely massive, compact, and dense pit with gravity so strong, not even light can escape, not even another black hole. They don't have a fixed point in space. Stars, planets, asteroids, comets, black holes, and everything in the universe is in constant motion. That's why things get so chaotic from time to time. Researchers found a giant black hole at the heart of one galaxy being eaten by an even bigger one. A black hole can get extremely big. At the centers of most giant galaxies are black holes that can grow millions to billions of times the mass of our sun. One of the ways to become so big is by eating others of its kind. A black hole merging with another black hole is one of the most energetic and powerful things in the universe. Picture this: 1.3 billion years ago, 2 black holes are circling around each other. The bigger one pulls the smaller black hole inwards, and now they're locked together in a spiral. Through time, that orbit starts decaying, but very, very slowly. These 2 black holes are constantly getting closer and closer. As they approach one another, the disks of orbiting dust and gases that surround them mix and create an intense towering vortex. It extends and goes pretty high above the center of that disk. At some point, they finally merge into one extra big, supermassive black hole. As they're merging, they kick out gravitational waves. These waves tell us a lot about black holes, but they can't reveal their precise position. So, scientists need some electromagnetic signal that will find the black hole's location, like radio waves, X-rays, or a flash of light. We can't see black holes, but we can detect their effect on space objects that are surrounding them. When a black hole passes through a cloud of matter, its strong gravity will pull matter inward. If a star or a planet comes close enough, the same will happen. The attracted matter then accelerates, which means starts to move very quickly and heats up. The black hole then starts emitting X-rays that radiate in the area surrounding it. The energy of X-rays affects the neighborhood and can, for example, spur the growth of new stars. And finally, bam! They collide. It's a massive burst of energy, one of the biggest bangs ever since the Big Bang. In less than a second, that collision emitted more energy than all of the stars in the visible universe together at the same time. Black holes can become huge, but not necessarily. Stellar mass black holes have a mass similar to the Sun, and they can be very small. The one scientists found in 2019 is located 10,000 light-years away from us and is only 12 miles across. They really have a reputation for destruction, but black holes are just another source of gravitational force, similar to stars. That means it's possible for a space body to orbit them, if it moves fast enough, of course. Let's say there's a black hole with the same mass as the Sun. The speed a space body would have to move at is the same as the one needed to orbit our Sun, if the distance is the same. That's a theory. In reality, planets don't really orbit black holes, because those that have a mass similar to our parent star are mostly the remnants of giant stars that ran out of nuclear fuel and eventually exploded. That's how black holes are created in the first place. And chances are that none of those planets nearby will survive it. But 30 years ago, scientists discovered the first planets beyond our solar system. These planets were found orbiting a pulsar, which is also some sort of supernova remnant. We don't know how they survived the explosion of their parent star. It's possible they may have been created after the destruction from debris that formed after the explosion. Scientists even have a theory that black holes are possibly wormholes, something like tunnels to other galaxies. That means they don't destroy objects they swallow, but send them somewhere. The theory says the object that enters and then goes out on the other side leaves the tunnel through something opposite of the black hole, a white hole. It probably looks similar to its companion, with all that spinning and similar mass. There could be a ring of gas and dust around the event horizon. The event horizon is the point of no return, the part of a black hole where nothing escapes. Unlike a black hole, a white hole lets light and all the matter leave, but none of that will be able to enter the portal once again. About 50 years ago, Stephen Hawking realized that black holes leak energy. Scientists then developed the theory that a white hole could be born out of a black hole. They're still not sure how the black hole disappears, but in this scenario, it would grow so small it no longer can have such strong gravity that makes it swallow other objects. So, it might turn into a white hole then. Such a hole would be similar in mass to something really light, like human hair. It wouldn't be so dramatic as its black hole ancestor, but it would still hide mysteries in its interior, the information of all space objects it had swallowed previously. It would eventually spit out that information and get so big, it would dominate the universe. White hole behavior, opposite of black holes and all that sucking the matter inward, could be compared to the Big Bang explosion, where the universe is expanding and new objects are forming. But even if something like this happens, it may only be possible trillions of years from now. And there's an issue. Even if some big white holes did form somewhere in space, they probably wouldn't last too long. Outgoing objects would collide with the matter in orbit, so the whole system would collapse and turn into a black hole once again, since they're also formed after supernova explosions. Stars, asteroids, comets, galaxies, and planets. all those space things we can see make up nearly 5% of the universe. About 25% could be dark matter, a mysterious substance we can't actually see, but assume it's there because everything in the universe moves to its gravitational tune. This dark matter is kind of like a spider's web. It holds all those galaxies that move pretty fast together. Its evil twin is called antimatter. Antimatter particles are like the opposite version of the matter, the same mass but opposite electric charge. When they collide, antimatter wipes out the regular matter, and the result is pure energy. Dark matter probably makes the universe expand even faster than it used to do. One of the latest theories says it could be responsible for the huge asteroid strike that made the dinosaurs go extinct, too. The universe doesn't have a center, but galaxies do. The Earth makes a circle around the center of the Milky Way once every 250 million years. This orbit is not straightforward, but we can roughly predict it. Once in every 60 million years, we go through the crowded region of our galaxy, known as the galactic disk. At the same time, we can track some harsh mass extinctions in the history of our planet, including the asteroid that wiped out the dinosaurs about 66 million years ago. Professor Rampino from New York University proposes that dark matter has a gravity that could throw nearby space bodies into the Earth's path whenever we enter the galactic disk. That means some asteroids and comets that would usually be far away from us are flung towards our planet. The biggest thing in the universe, at least the one we know about, is the Hercules Corona Borealis Great Wall. It's a cluster of galaxies 10 billion light-years across, bound together by gravitational force. The biggest elliptical galaxy is IC 1101 and has a diameter of 4 million light-years. The smallest galaxy, Segue 2, we've discovered so far, has a diameter of a little bit over 220 light-years. It's pretty faint and has only 1,000 stars. For comparison, our galaxy has 100,000 million stars. It orbits the Milky Way.